Lecture outline, numerical on continuous beam. So this video is the second part of previous video. So in our first part we were dealing with the fixed end moment. We gone through the distribution factor and moment distribution table. This is second part. In second part we are going for moment, bending moment diagram. So this is given figure, a loading diagram. Span AB, point load 8 kN, unsymmetrical, acting at a distance of 3 meter from A and 1 meter, let's call it as B, 1 meter from B support. So first find out free bending moment value. So for point load, unsymmetrical point load, the equation is WAB by L. A means 3, B means 1, load is 8, putting the value, and span is 4, we have 6 kN meter. BC span, point load at mid, equation is WL by 4, W is 10, span is 3 divided by 4, so 7.5 kN meter. Span CD, equation for UDL is WL square by 8. So W is 4, L is 3. So 4 into 3 square divided by 8, we are having free end moment 4.5 kN meter. Now draw the free bending moment diagram first. So 6 in triangle, 7 is 7.5 in triangular fashion, and UDL in parabolic fashion 4.5 kN meter. Now next is final end moment. So final end moment value is positive 1.657. So how to draw it? Whether it should be up or whether it should be down. So it depends upon the sign convention. For positive you have to take anti-clockwise, for negative you have to take clockwise sign. So your first AB value is plus 1.657. So keep your pen over member AB and rotate about joint A in anti-clockwise sense likewise. So it arrow coming up, so you have to show up. Next is minus 4.166. So keep your pen over the member BA and rotate about joint in clockwise sense. Arrow coming up, so show up 4.166. Next value is positive 4.166. So keep your pen on member BC and positive value, that means you have to rotate in anti-clockwise sense about joint B coming up, so you have to show up. Next is minus 3.969. Now keep your pen over the member BC and rotate about joint C in clockwise sense. So rotate about joint C in clockwise sense, arrow coming up, so you have to show up 3.969. Next one is positive 3.969. So again positive value for CD. So keep your pen on CD close to C, positive sign, so you have to rotate in which sense? Anti-clockwise sense. So rotate in anti-clockwise sense about C, arrow coming up, so you have to show value up. That's why this value is up 3.969. Join all the end moment. So we having bending moment diagram. Now the portion which is single, that you have to make hatch. Now this white portion is overlap portion of your free bending moment diagram and fixed bending moment diagram. So whatever the portion, now let's say this one is your pre bending moment portion, and next is your end moment portion. Okay, so this is a single one, they are not overlap, so make it hatch. So this portion not overlap, so make it hatch. But this portion, white portion, is overlap portion, so keep it as it is. Okay, so same way you have to do single portion, you have to hatch. So this is single portion, so hatch it, and overlap portion keep as it is. Now the value, the portion above this line indicate your end moment line. This is your end moment values. So portion above this end moment line is your positive moment. So positive moment, and below it negative moment. Okay, so this is about bending moment diagram. Now next one is shear force diagram. So for shear force, first draw the free body diagram of each span. First is 8 kN and find out reaction at each end. So by taking moment about this end, you will get reaction for A and reaction for B, and doing summation Fy. So by taking moment here, you will get reaction at B, and that value is 6. And taking summation Fy, you will get reaction at here, that value will be 2. Same way find out for this span, 10 kN loading, reaction, your reaction will be half 5, because the loading is symmetrical. For here it become 4 into 3 become, load into span become 4 into 3 become 12, 12 by 2 it become 6. Okay, so these are the reaction from the loading. By just doing summation Fx, summation F, moment about any joint, you will get reaction, vertical reaction or shear force due to the loading. Now next one, draw for end moment. So end moment at A is positive 1.657, that's why anti-clockwise, and minus for clockwise. So according to their sign, you have to show at the end. These are the end moment. Now next one, find out unbalanced moment. So take a difference between these two, 4.166 minus 1.657. You having an unbalanced moment here for this end, 2.509. Take difference between these two, and you having an unbalanced moment of 0.197. Now here unbalanced moment at this end, there should be balance. To make it balance, there should be moment in opposite direction, but that is not there. So unbalanced moment remain as it is, and that is 3.969. So this is unbalanced moment. So these are the value of unbalanced moment. So make it balance now. So how to make it balance? You have to apply the couple in opposite direction to this. So how to find that? 2.509 divided by span. Span is 4. You having a 0.627 value. Now below this maximum moment, you have to show the line and show the arrow in such a way that it will create moment opposite to this at opposite end. So if you rotate, if you keep arrow off, it will rotate and create moment opposite to this. So this is in which sense? This is in clockwise sense. So by keeping arrow off, automatically your moment will be rotated in anti-clockwise sense. So again I repeat, this is unbalanced moment 2.509 divided by span 4, you having a value 0.627. show it below maximum and keep it up, so it will add in this minimum moment. Okay, so when it add in this minimum moment, it will automatically balance this 4.166. so show arrow up. If it is up, it should be down, show it down, same magnitude. This is first way. In second case, unbalanced moment is 0.197 divided by span 3, you are having 0.066. so first show it below the maximum one. No, this one is a maximum value, so show it here. And your minimum moment is this one, so it should be rotated, the arrow should be up. So when it rotate, it will added here. If you rotate, it will make balance to this one, so its arrow should be up. If this arrow is up, this show this arrow down, 0.066. Now next one, 3.969 unbalanced moment divided by this span 3, you are having a value 1.323. Now how to show the arrow? First locate below the maximum moment, this is maximum moment 3.96, and show arrow up. Why up? When it rotate, it will create moment in opposite to this, so that you have to show up. If it is up, opposite end, you have to show directly downward direction, same magnitude. So likewise you have to draw the reaction due to unbalanced moment. After completing this, add reaction due to unbalanced moment and reaction due to the load. These two you have to add. Consider their sign convention. So here our value is 2 kilonewton. 2 plus 2 plus 0.627, it become 1.2 minus, sorry, it is downward, so minus you have to take, it is plus. And here I think here reaction is 6 to the loading, so plus 2 minus 0.627 become 1.373, plus 6 plus 0.627 becomes 6.627 kilonewton. Now here is 5 plus this value 5.066, here is 5 plus this value become downward, so minus become 4.934. Again this value is 6 plus 1.323 becomes 7.323, and last value is 6 plus 6 minus this 1.323 become 4.677 kilonewton. So these are the final reaction. Now draw the shear force diagram from this reaction. So plus up, that's why 1.373 positive, this is total addition is 11.693 kilonewton. Addition of these two, again addition of these two is 12.257, and last one is as it is. So 4.37, 1.373 no loading, straight line, then minus 8 will become 6.273, straight line, no loading. Then again you have to move up, minus 11.693 you become 5.066, no loading up to 10, then minus 10 you having a 4.934, no loading, so straight line, and reaction is 12, so minus 12, and this minus 4.939 become 7. This value is there, so you may directly take from here, from this 7.323, and last value UDL, if you take minus 4 into 3 you will get 4.677. okay, so for point load, vertical line, no loading, horizontal line, or UDL, inclined line. Okay, so this is your shear force diagram. Okay, thank you.